Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let us look at some example problems. Let us look at examples using difference of two functions. Let us say we have an example of this kind. Y equals to integral x minus 8 dx. We have a function x minus 8. We're going to use the difference rule of integration and then separate them out as shown here. We can write it as integral x dx minus integral 8 dx. Now, we're going to use for integral x dx, we're going to use the power rule, and we're going to use the constant rule of integration for integral 8 dx. So x to the power of x means x to the power of 1. We're going to use the power rule for this part of the integration and then problem, and then we're going to use the constant rule of integration for this part of the problem, integral 8 dx. So integral x means integral x to the power of 1. When we perform the integration process, x to the power of 1 simplifies to x to the power of 1 plus 1 divided by 1 plus 1 plus c1, where c1 is the constant of integration for this part of the problem, minus integral 8 dx. When we integrate that, 8 is a constant. We're going to take it outside of the integration process. Integral dx converts to x. So 8x is what we have, plus C2 is the constant of integration for this part of the integration, for this part of the problem. So now we're going to simplify that some more. X to the power of 1 plus 1 is x to the power of 2. In the denominator, we have 2 minus 8x. Since we have a negative sign here, negative times 8x is negative 8x, plus C1 minus C2, plus C1 minus C2. So C1 is the constant of integration for the first part of the problem. C2 is the constant of integration for the second part of the problem. So we're going to combine these two, C1 minus C2, as another constant C, and then simplify it as follows. X to the power of 2 divided by 2 minus 8x plus C, where C is the constant of integration. As we mentioned, C, the constant of integration, will be added to the solution of the when we complete the integration process. So this is how we're going to use the difference of two functions rule to solve simple example problems. Let's look at another example. Let's say we have an example of this kind. Y equals integral x to the power of 5 minus 10 dx. We're going to use the difference of two integrals rule to solve this particular problem. We can write this as integral x to the power of 5 dx minus integral 10 dx. Okay, so now we've written it out in this form because we know that x to the power of 5, for integral x to the power of 5 dx, we can use the power rule, and for integral 10 dx, we can use the constant rule of integration. So when we integrate x to the power of 5, we have x to the power of 5 plus 1, the whole thing divided by 5 plus 1, plus c1, where c1 is the constant of integration for the first part of the problem, minus, we have a negative sign here, open parenthesis, integral 10 dx. 10 is a constant, so we're going to take that outside of the integration process. 10 integral dx converts to x, so 10x plus c2. C2 is a constant of integration for the second part of the problem. So when we simplify this some more, x to the power of 5 plus 1 converts to x to the power of 6. In the denominator, we have 5 plus 1, which is equal to 6, minus 10x. Minus of 10x is minus 10x, plus c1 minus c2. Again, we're going to combine c1 minus c2 into another constant called c, and then write the final solution as shown here, x to the power 6 divided by 6 minus 10x plus c, where c is the constant of integration. Constant of integrations are always added when we arrive at the solution in the integration process. In my next video presentation, we will be solving problems using the rules of integration.